Unit 4.4 Special Quadrilaterals. These special quadrilaterals, rectangles, rhombuses, and squares, are special kinds of parallelograms. They're not just quadrilaterals, they're parallelograms. So, first of all, when we talk about a rectangle, rhombus, and square, they're automatically going to have the 6 properties of all parallelograms. Both pairs of opposite sides are parallel, both pairs of opposite sides are equal, both pairs of opposite angles are equal, consecutive angles are supplementary, the diagonals bisect each other, and each diagonal forms a pair of congruent triangles. Since these 3 special types of quadrilaterals are also parallelograms, they possess those 6 properties of all parallelograms. But they also possess some special properties of their own that not all of the other ones necessarily possess. The first of which would be their individual definitions. The definition of a rectangle is a quadrilateral having 4 right angles. A quadrilateral having 4 right angles. Now, since they're all 4 right angles, then that means they're all equal, which means it is an equilateral meaning the sides are the same, an equilateral quadrilateral. Now, a rectangle of the stretched out fashion has 4 right angles, but also a rectangle not stretched out where the sides are all the same, being a square, is also a rectangle. See, a square is a rectangle because it fits the definition of having 4 right angles. So a rectangle is a special type of parallelogram, a special type of quadrilateral, but then a square is even a special type of rectangle. A rhombus, by definition, is a quadrilateral with 4 equal sides. A quadrilateral with 4 equal sides. Now, equal, I said that wrong a while ago, didn't I? I said equilateral, quadrilateral. It's not equilateral when all of the angles are equal. It's equiangular. Excuse me, I'm going to write that down just to correct myself better. Equiangular quadrilateral. A rhombus is a quadrilateral with 4 equal sides. The fact that it has 4 equal sides means it is equilateral. There's the equilateral. So a rhombus is an equilateral quadrilateral. A rectangle is an equiangular quadrilateral. A rhombus shape is a diamond shape, but by definition, it's 4 equal sides, and a square has 4 equal sides. And so a square is a special type of rhombus. So a rhombus is a special kind of parallelogram or a special kind of quadrilateral, and then a square is a special kind of rhombus. So a rectangle is an equiangular quadrilateral. A rhombus is an equilateral quadrilateral. A square is both equilateral and equiangular, which we have a fancy name for that, and that is regular. A square is a quadrilateral with or having 4 right angles. the definition of a rectangle, and 4 equal sides, the definition of a rhombus. The fancy word for being both equilateral and equiangular is regular, and so a square is a regular quadrilateral. So far on these, we have the first 6 properties of all parallelograms. Both pairs of opposite sides are parallel, both pairs of opposite sides are equal, both pairs of opposite angles are equal, so consecutive angles are supplementary. The diagonals bisect each other, and each diagonal forms a pair of congruent triangles. We would add to that list of 6 on a rectangle its definition, which says it has 4 right angles. To a rhombus, we would add to that list of 6 its definition, which says it has 4 equal sides. And we would add to that list of 6 on a square its definition, which says it has 4 right angles and 4 equal sides, which now gives a square 8 properties. But that's not all the properties. We just added those because of the definitions. Now we have the first 6 properties of all parallelograms. When we add in the definitions, we now have 7 properties for a rectangle, 7 properties for a rhombus, and 8 properties for a square. Another thing that is true on a rectangle is that the diagonals are equal. Now, we already know that the diagonals bisect each other, and we already know that a diagonal forms a pair of congruent triangles. If we had a Rhombi parallelogram, as I call it, you can see evidently that one diagonal is longer than the other one. If we were to push it that direction, in other words, make it not Rhombi anymore, then what would happen is as you pushed it so that the angles became 90, those diagonals would become the same length. So in a rectangle, the diagonals are equal. Now, look what's going to happen because of that. In a Rhombi parallelogram, they bisect each other, so those 2 little pieces are equal, and those 2 little pieces are equal. In a rectangle, they were equal to begin with, and then they bisected each other, so all 4 of those little pieces are equal in a rectangle. So now we have 8 properties of a rectangle. Both pairs of opposite sides are parallel, both pairs of opposite sides are equal, both pairs of opposite angles are equal, consecutive angles are supplementary, the diagonals bisect each other, each diagonal forms a pair of congruent triangles. That's the first 6 properties of all parallelograms. We added to that list the definition of a rectangle, which says all angles are 90 degrees, and then the property that the diagonals are equal. 8 properties of all rectangles. Notice that these 2 angles turned out equal because this is an isosceles triangle. And if 2 sides of a triangle are equal, then the angles opposite those equal sides are equal. Also notice that those are equal because that's an isosceles triangle. And if 2 sides of a triangle are equal, then the angles opposite those equal sides are equal. So there's some other special little things that begin to happen as we begin to get a bunch of equal pieces, which creates a isosceles triangle, and then all the isosceles triangle rules begin to apply, you see. Properties of a rhombus. Obviously, the first 6 properties of a rhombus are the first 6 properties of all parallelograms, which say that both pairs of opposite sides are parallel, both pairs of opposite sides are equal, both pairs of opposite angles are equal. Consecutive angles are supplementary, the diagonals bisect each other, and each diagonal forms a pair of congruent triangles. Now, when we think about a stretched out, humpy jawed parallelogram, ooh, that didn't work good. I should have created these in GeoGebra or in the geometric sketch pad, and then I could pull them and twist them, but I can draw them about as fast as I could pull those things up. Those are very good applications, though, if you have access to those, because you can ask for the angle measures, and as you bend and twist it, you can see them change as you go. So they're wonderful applications. I don't have those created, so I'm just going to create it here. Notice that when we have it elongated and whimper-jawed, that we have a big angle and a little angle. Those two angles were not the same. Now, what would happen is if we began to push this side in so that it became a rhombus shape, that when we draw those diagonals, they look like they're almost 90. And when we finally get them pushed together so that it is not an elongated parallelogram, in the case of a wumpy-jawed rectangle or a rectangle, when it becomes a rhombus, then we no longer have a big angle and a little angle adjacent to one another as those diagonals cross. When we make all the sides the same, then they hit at 90 degrees, and so we can say that the diagonals of a rhombus are perpendicular. Now, the definition of a rhombus was all four sides are equal. Notice also, though, as we look at this elongated parallelogram, be it whimper-jawed or a regular rectangle, when you draw a diagonal, if it's elongated, then those two little angles are not the same. In other words, this angle and this angle are not the same when it's elongated. But when we made the sides the same, then those two little angles were equal, and those two little angles are equal. In other words, each diagonal bisected a pair of opposite angles. Each diagonal bisected a pair of opposite angles. This diagonal didn't bisect that. When it's elongated, the sides are not all equal. The diagonal did not bisect that. So another property of a rhombus, because all four sides are equal, then the diagonal bisects a pair of opposite angles. So the properties of rhombuses are the first six properties of all parallelograms. Both pairs of opposite sides are parallel. Both pairs of opposite sides are equal. Both pairs of opposite angles are equal. The diagonals bisect each other, and each diagonal forms a pair of congruent triangles. That's the first six. The seventh, which I've got number 9 here, is the definition that says that all sides are equal. And then the other two properties of a rhombus have to do with their diagonals, and it is that the diagonals are perpendicular and that each diagonal bisects a pair of opposite angles. Each diagonal bisects a pair of opposite angles. Okay? Now, remember, a square is everything. A square is a parallelogram, a square is a rectangle, and a square is a rhombus. So it has all of the above properties, which means that it has 11 properties. The first 6 properties are the properties of all parallelograms. Both pairs of opposite sides are parallel. Both pairs of opposite sides are equal. Both pairs of opposite angles are equal. Consecutive angles are supplementary. The diagonals bisect each other, and each diagonal forms a pair of congruent triangles. The other ones are the fact that it is a rectangle. The fact that it's a rectangle says that all of its angles are 90. And because it's a rectangle, the diagonals are equal. The other properties come in because it is a rhombus. The fact that all sides are equal makes it a rhombus, and we get these two additional properties because they're the properties of a rhombus in that the diagonals are perpendicular and each diagonal bisects a pair of opposite angles. So all squares have 11 properties. Okay? And you can study all of the fine print where we filled all that in to show all the little bitty pieces that are equal. And then we've got this little theorem thrown in on top of all of that, which says the midpoint of the hypotenuse of a right triangle. Remember that a right triangle is a triangle with one right angle. The side across from the right angle is called the hypotenuse, and the other two sides are called legs. This little theorem says that the midpoint of the hypotenuse of a right triangle is equidistant from the three vertices of the triangle. Now, what that means is the distance from the midpoint to this vertex, the distance from the midpoint of the hypotenuse to this vertex, and the distance from the midpoint of the hypotenuse to this vertex are all the same, which means that segment DA is equal to segment DB, which is equal to segment DC. Segment DA is equal to segment DB, which is equal to segment DC. The midpoint of the hypotenuse of a right triangle is equidistant from the three vertices of the triangle. The midpoint of the hypotenuse of a right triangle is equidistant from the three vertices of the triangle. Okay? All right. We're going to go ahead and I'm going to go ahead and stop that recording. That was a little bit longer. This will help on the download speed, and then we will record the daily work in a moment.